Well, welcome back to our next installment of looking at descriptive data analysis in our first week together. Right now we're going to pick up where we left off and look a little bit more in detail at measures of central tendency and interpreting those measures, and then follow up with a discussion about variance within the data. So, as we've said before, we're using the Emory Roadmap for Data-Informed Health Transformation to guide our discussion in class, and we're here still looking at methods for exploring data and variables. I've talked already about central tendency. We're going to revisit that in a bit more detail. And we're going to spend some time looking at data distributions and variance today. So let's begin with central tendency and variance and see how these two concepts are related to each other. First idea of central tendency we've talked about as the mean and the median as two measures of central tendency, and looking for the center point of all of our variables, or rather all of the values for a particular variable. And variance now builds on the concept of central tendency, and it shows you how much the data vary around that central measurement. And some standard measures that you'll see quite extensively in the literature are the standard deviation and the interquartile range, as well as the range of all data points from 0, or for the lowest point, to the absolute highest point, as well as the minimum and maximum. And so the difference between the minimum and the maximum gives you your range. And so those numbers show you how the data points are distributed around the point of central tendency. So by way of review, we've already talked about how the mean of a variable is the total of all that variable scores divided by the number of observations. And in this data set, for the number of heart failure discharges per hospital facility, you can see here that the mean is calculated at 400. And when we look at these data, you can also see that the mean visually is falling in and around 400. So it's that central measure of the total of all observations divided by the number of observations. The median is a bit different. If we look at hospital discharges and we ran our box plot, we saw that the median was around 300. It's in the lower third between 0 and 1,000. So on average, the median number of discharges that a hospital facility conducts in the United States is about 300. Now when we look back at the histogram, we see that the mean was 400, and from our box plot we saw that the median was 300. So we see that there's a little bit of discrepancy between the median and the mean value for the average number of hospital discharges by facility. So let's begin now to look at how the variance for that average number of hospital discharges for heart failure affects our understanding. Now, when data are normally distributed, the mean and the median value for that variable are essentially equal, very, very close to each other. In a truly normally distributed variable, they would be absolutely equivalent. But for all intents and purposes, in looking at biomedical data, we're looking for an approximation of equivalence between the mean and the median. And so let's take a look at an example of that within our data set. We see here for heart failure readmissions, the excess ratio, which is used to calculate the hospital specific penalty for readmissions, is a standardized ratio. And if you see here on the left the number of hospitals with this particular ratio, we look at the ratio of 1. So those are the hospitals whose number of readmissions is approximately equal to the number that are predicted for that facility. We go up and we can see that approximately 210 to 215 hospitals have a excess readmission ratio of 1. And when we look at the statistical data displayed in the top right corner, we see exactly that pattern, that the actual calculated mean is in fact 1.0015, so it's essentially 1. And the median value is calculated at 0.9984, so you can see that these two numbers are essentially equal. And so in this data distribution, the mean and median are almost identical, and that's very characteristic of a normally distributed variable. So again, in normally distributed data, the mean and the median are essentially equivalent. Let's take a look at left-skewed data. And in those situations, instead of a normally distributed bell-shaped curve like we saw on the previous slide, the data are going to be heavily shifted to the left-hand side of that curve on this side. But the mean value for those data, the value is going to be higher, greater value than the median. So let's see how that plays out visually with a variable from our data set. You can see here the number of readmissions for heart failure graphically displayed. If we look at the left side of the graph, these are 0 readmissions for heart failure. And the right-hand side of the graph, we go up to 1,000 readmissions for heart failure. And the vast majority of those readmissions are happening on this left side of the curve. So if we calculate the statistics, we find that the mean number of readmissions is 90. And that's depicted here. And the median number of readmissions is 66. So the statistical findings that we calculate the actual mean and median are consistent with the visual demonstration a plot of these data, showing that the majority of observations are happening here on the left-hand side of the distribution. So this is consistent with a left skew. You have a median value that's less than the mean. So that's showing you that more observations So again, that's a picture of a left-skewed distribution where more observations are happening on the left side of the curve than on the right. That occurs when the median is less than the mean. Let's look at a right-skewed distribution. This occurs when your median value is now greater than the mean. And let's see an example of that from our data set. Now, these data are about the proportion of facilities who give patients discharge instructions. So on the left-hand side of this graph, we have the number of facilities that give discharge instructions, and on the bottom, we have the proportion of facilities who give those instructions. So when we calculate the mean, we can see that 94% of facilities give discharge instructions. But when we calculate the median, we see 97% give those discharge instructions. So here is a clear example of the median value being greater than the mean, and that suggests again that most observations are happening on the right-hand side of the distribution instead of the left. So again, the mean value is less than the median value in a right-skewed distribution. So now that we've looked at the distributions and how mean, median, and mode could be used to understand the distribution, let's look a little bit at variance. And specifically, how do we interpret variance? What does it mean? So variance is the spread of data around the measure of central tendency. The standard deviation is often used to describe the variance, how the data are spread around the mean for a normally distributed number. And conversely, the interquartile range to describe the 25th percentile and the 75th percentile is the convention used to describe the variance around a median for data that are not normally distributed. So I'd like to take a look at how variance plays out within our data set with a few examples. So let's look here at the number of discharges for heart failure. We want to see how different are the values in this data set from our measure of central tendency. So let's first begin by looking at the mean of these data. When we run the statistical analysis, we see the mean's 400. And so I've plotted that here for you on the graph to show where the mean value lies. If we look at the standard deviation of 350, that means that 66% of the observations occur 350 points below the mean to 350 points above the mean. So if we take the mean value of 400 and subtract one standard deviation, we get 50. And if we add one standard deviation of 350, we get 750. So these dots on the purple bar are at approximately the 50 and 750 mark. So that the variance there, the large spread, shows you how much diversity there is in these data. And given a mean of 400, a spread of nearly 700 points on either side is quite a large amount of variance. Now let's take a look at a small amount of variance when the measures around the central point are quite similar. So this again is the histogram looking at the proportion of facilities who give discharge instructions to patients. We can see from these data that the median value is 97, which is also equivalent to the 50th percentile. So here's the median value plotted on the graph. Now when we look at the purple dots, that is the interquartile range. So it's the range from the 25th to the 75th percentile. And you can see from the calculated numbers, the 25th percentile is 93% right here. And the 75th percentile is 100%. So the total range around this median is only 7 percentage points. So it's a very narrow range of diversity around that median. And this graph shows you the same thing as the numbers. You can see that almost all of the numbers are clustered right here around the median. So let's briefly review how the variance, or the spread around the measure of central tendency, and the measure of central tendency itself are related. So we look at this graph, and we'd like to describe the distribution of the data, the measure of central tendency that would best describe the data, and the amount of variance. So I'd like you to pause the video for a second and just review. How would you describe this distribution? Is it normal, left skewed, or right skewed? What measure of central tendency might best describe it? The median or the mean? And how much variance is there around that measure of central tendency? So you'll see that these data are normally distributed. The mean and the median value are essentially the same. And so a mean or a median either could be an appropriate measure of central tendency to describe the breadth of variance around the central measure. This graph, I'd like you to do the same thing. Can you describe the distribution, best measure of central tendency, and how you describe the variance? So these data are heavily right skewed, and because of that, the measure of central tendency that's optimal for these data would be the median. And the variance is very small, only between 93 and 100, so 7 points in total. So practice with this graph as well, and pause the video after you have a chance to review, and test your knowledge. I'd like to thank you for our engagement on measures of central tendency and variance and welcome you back to our next session momentarily.